For each of the coin, we might pick it, we might not pick it. So for each of the combination, or we can say that in this case, we have 2 to the power of n possible combinations. And out of these combinations, some of them does not work if we are picking any 2 coins next to each other. And for the rest of the combinations, we probably need to calculate the sum of coins that we picked. So the complexity in this case might be 2 to the power of n. And by using dynamic programming approach, as we discussed in the lecture, what happened is that instead of considering all these coins at the same time, let's try to consider each of the coin one by one. So if we have 20 cents, 50 cents, 20 cents, then we have 5 cents, 10 cents, 20 cents, and then the last 5 cents. What I'm going to do is, let's say, this is starting an array called A, and I'll now create another array called V. V stands for the total value. So if we only give you the first coin available, for example, what I'm going to have is, I'm going to hide the rest of the coins and ask you, what is the highest amount of money you can get in this case, if we only have 20 cents? I think this should be obvious. If we only have 20 cents available to us, we'll surely pick it. And by picking only this 20 cents, we're going to get 20 cents as the total amount of money we can get. All right, then we go one step further. Now we have one more coin available to us. We also have this 50 cents. Now I think we have 2 options. We'll either take this 50 or we are not taking 50. And if we are taking 50, well, let's consider the easier case. If we are not 50 cents, what is the maximum amount of money we can get? So I think in the array V at index I, we have 2 possibilities. We can take that coin, or we may not take that coin. And if we are not taking that coin, I think the maximum amount of money we can get would be exactly the same as what we had in the past round. So that's VI minus 1. In our case, if we are looking at the coin 50 cents, then the maximum amount of money we can get without taking the 50 would be same as the maximum amount of money we can get as if we don't even have this 50 coin available to us. Right? So we can simply take the value in front of the cell that we are looking at. And the other chance is that we may take that 50 cents. And if we take that 50 cents, then we cannot take any of the coin next to it, which means we cannot take the previous coin. In our case, it's 20 cents. So if we take it, of course, that AI would be part of the coins, or one of the coins we are taking. Now, how about the other coins we can take? In this particular case, when we are looking at this 50 cent coin, looks like if we take this 50, we cannot take any other coin because we only have 2 coins available, right? So I'll just put AI here, but I'll put a question mark here indicating that maybe we can take something else, but in this case, looks like we can only take 50, right? Then we have 50 here. Now we go one step further. Give one more coin to us, we have one more 20 cents. And if we are taking this if we are not taking this 20 cents, I think the maximum amount of money we can get would be taken from the past round, so we get 50. And if we are taking that 20 cents coin, what will be the amount of money we can get? That means we can take that AI, which is 20, then what else we can get? We know that we are taking the third coin. It means that we cannot take the second coin. then it means that we may take the first coin if we want. So I think here what we get is, if we are taking AI, the coin AI, then we can at the same time get the maximum amount of money from the beginning of the array to the index I-2. Does that make sense? And that's exactly the value of Vi-2. If we are taking the coin AI, then we cannot take AI-1, but we can take AI-2 if we want. So we are trying to find what's the maximum amount of money we can take from index 0 to index I-2. And it looks like we've already solved the problem. We should have Vi-2 as the value we are interested in. So I'll put it here, saying that if we are taking that coin, then the maximum amount of money would be the value of the coin we are taking, and also the best combination that we found 2 rounds ago. Now, for this 20 cents, I think if we are not taking it, then the highest value would be 50. If we are taking it, then we have 20 plus 20 giving us 40. And of course, we want to maximize the profit we get, so we're going to have 50 here. I think this recurrence relation can be then used for any other coins in this sequence. For example, for this 5 cents, if we are not taking it, then the maximum we can get would be 50. If we are taking it, then we can at the same time take this 50. Then it will give us 55 as the maximum amount of money we can get. Then we keep going. For the next coin, which is 10 cents, if we are not taking it, then the maximum would be 55. If we are taking it, then we also get Vi-2, which gave us 50. So 50 plus 10 giving us 60. Looks like this is the best we can do. Keep moving to the next coin. We have another 20 cents. So if we are not taking it, we have 60. But if we're taking it, then we get 75. And for the last coin, 5 cents, if we are not taking it, we have 75 cents in total. If we are taking it, I think the maximum we can get would be 5 plus 60, giving us 65, which is smaller than 75. So it means we should not take it, and we will end up with 75 cents in total. I think that's it. By looking at the last value we store in this array, it tells us what is the maximum amount of money we can get. And it solved this problem. Of course, if we just do this, if we only use one single additional array V here, looks like we can only get the maximum amount of money we get, but we cannot know which coins we've picked and which coins we have not picked. But of course, we can use another array I'll call P, indicating whether we are picking a coin. Then every time when we calculate a value in the V array, if we take that coin, we can change the value to true in the P array. If we are not taking that coin to get the maximum amount, then we can have a false in that coin. I think this could help us to find out for each of the, well, this can help us to find out for each of the coin whether we should take it or we should not take it in order to maximize the total amount of money. A question from the chat window. Why the third element in the array V is 50 rather than 40? Remember what we store in the array V. V stores the value such that if we have coins up until that coin, what's the maximum amount of money we can get? Now, if we have these 3 coins available to us, if you pick the first coin and the third coin, you get 40 cents. But if you're only picking the second coin, you get 50 cents. So of course, 50 cents is the best choice we have. And as we just mentioned, to calculate the V value, we have two options. If we are taking it, we can also take the maximum profit we can get from 2 rounds ago. And if you're not taking it, we simply copy and paste the value from the past round. So of course, we should consider, if we are not taking that coin, what is the maximum amount of money we get? And that's also the reason we get 75 for the last 5 here, because we know that if we take that 5 cents, we can get only 5 plus 60, that's 65 cents in total. But if we are not taking it, then the maximum we can get would be from the second last round, we get 75. Now, if we consider the time complexity of this approach, we had the array A as the input, and what we did, we had an array V initialized, which takes linear time. Then for each of the cell in this array V, looks like we only need to consider 2 different scenarios. The first scenario, when we are not taking that coin, we're simply taking an element from the same array. And for the other scenario, when we are taking the coin, we are accessing one element in the array A, we are accessing another element in array V, and adding up them together. And we simply compare these 2 scenarios to find a larger value and fill into that cell. So I think for each of the cell in the array V, we only take constant time to find this value and then storing it. And of course, at the end of the algorithm, we will simply need to return the last value in the array V. So in this case, we will just return 75 as the maximum amount of money we can get. So I think overall, the algorithm will have linear complexity. Recall the brute force approach that we just mentioned at the beginning of the session. We're going to have 2 to the power of n as the time complexity, because for each of the coin, we might pick it, we might not pick it. I think you should be familiar with it after doing the first assignment. All right, I think that's it for the CoinRow problem. And the dynamic programming idea used here is that, generally dynamic programming means that we have a problem that we may be able to break into sub-problems. And the solution to the sub-problem might be reused later on to help us solve the original problem. Remember, what are the sub-problems here in our CoinRow problem? The original problem is, what is the maximum amount of money we can get from the sequence of these 7 coins? And one of the sub-problem is, if we only have the first coin, what's the amount of money you can get? And one of the sub-problem is, if we only have the first 2 coins, what is the best choice you can get? And so on. And we can see that from this recurrence relation that if we want to find out the maximum amount of money we can get if we have I number of coins in total, then we need the result from I minus 1 coins and also I minus 2 coins. So we use the result of these 2 sub-problems to help us to solve a larger problem. And I think in this case, if we want to have the recurrence relation, we should have VI represented in whatever I have on my screen. And we have 2 base cases. The first base case should be, for the first element, if we only have 1 coin available, we will surely take it. And for the second value here, what should we get? If we have 2 coins available, we can only take 1 of them. So we are picking a larger element. So we will be taking maximum of A0 and A1. So we have these 2 base cases. And for any other I value greater than 1, we will use this